All right, so what I'm going to do is I am going to do a problem here. The problem that I want to do is to find an inflection point for for y equals x to the 4 over 2 plus 3. So problem, right? So find an inflection point find an inflection point for y equals x to the 4 over 2 plus 3. Okay, so I have this function here, and they want me to find an inflection point for it. So I'm going to try to an inflection point. All right? I'm going to try to find an inflection point. So what I'm going to take is the derivative of this function y of x, right? So this is the function y equals 2x to the 4 over 2 plus 3. Now I can actually plot this, graph it, and look at it. But I don't need to do that. I want to find an inflection point. So what I'm going to do is I'm going to take the derivative of this polynomial. Okay, so I'm going to take the first derivative of this. So y prime is equal to 4 times y to the 4 minus 1, which is 3, divided by 2 plus 0. Okay, now I'm going to take the second derivative of this expression, y equals x to the 4 over 2 plus 3. So we get a y double prime. I'm taking the derivative again of this. Is going to be equal to 12. Okay. Sorry, this is not a y here. I apologize. Silly me. Right? Very silly. Let me erase this here. All right, so this is going to be x cubed All right, so I'm taking the derivative of this again, and it's going to be now 12x squared over 2. And so this really is so this says that y prime really is equal to y double prime, sorry, is equal to 6x squared. So now to find possible inflection points, I'm going to look for where the second derivative is equal to 0. Okay, possible inflection points. The fact that the second derivative is equal to 0 at that point does not translate into that being an inflection point. But so I'm going to solve the equation 6x squared, right, is equal to 0. And this implies that x squared equals to 0. So really then that says that x is equal to 0. That's the possible inflection point. Okay? So now what I want to do is the domain of this function being a polynomial, so note the domain of y, of the function here, domain of this function being a polynomial is from negative infinity to infinity. It's the whole line, the whole real line. Okay? So I am going to see what is happening to the concavity of this function between negative infinity and 0. So I'm going to look at what happens to this function, whether it's concave up or concave down between negative infinity and 0. Okay, so I'm going to test for concavity between negative infinity and 0. Then I'm going to test for concavity between 0 and infinity. Now, if the concavity changes from here, unless that happens, we don't have we're not dealing with an inflection point. Certainly, we are sure. Okay, so let me take a point, any point between negative infinity and 0. So I'm going to take the point, let's say -1. Okay, I'm going to take the point -1 there. And over here, I'm going to take the point, let's say 1. That point is contained between 0 and infinity. This one is contained between negative infinity and 0. So now what I'm going to do is I'm going to plot the point -1 into y double prime equals to 6x squared and see what I get. If I plug in -1 in here, this implies, or this equals, if I plug in -1 in here, this expression becomes 6. So this is concave up. It's concave up, okay, because it is positive. Now if I take the point x equals 1 here, and I plug it into y double prime, I also get 6 times 1 squared is equal to 6. So what ends up happening is that the concavity does not change, right? So the concavity does not change. Let me actually... The concavity does not change, okay, from negative infinity to 0 and from 0 to infinity. So what this is telling us that the point x equals 0 does not lead to an inflection point, okay? So note, so let me actually write this down. Since concavity, okay, does not change before and after 0, before, right, and after 0, the value x equals 0 does not lead to an inflection point, okay? The value x equals 0 does not correspond to an inflection point. Okay, does not correspond to an inflection point. Okay, so that's how we know that this expression y, or this function, if you will, y equals to x to the 4th over 2 plus 3 does not have inflection points. All right? Now, many people assume that because the double derivative was 0 when x was equal to 0, that this expression, or this function, here, many people assume that this function had an inflection point at x equals 0, and that is absolutely false. So there is no inflection point for this. Thank you for listening.